Welcome guys to this new video. In this video we will be solving the Fibonacci numbers problem. We have here two problems. The first one is finding the nth Fibonacci number and the second one is finding the first nth Fibonacci numbers. First, let me write what is the Fibonacci number sequence. So it starts from, it begins with the number 1 and 1, and then it starts from there. So it's just adding the previous two numbers to get the next number. So the result of adding 1 and 1 is just 2, and then 2 and 1 is just 3. So 3 and 2 is just 5, and then so on and so forth. So this is the Fibonacci sequence, and if we want to get the nth one, as I said, we need to add up the previous two numbers. For example, if you want to get the fifth one, we don't need to add 4 and 3. We need to add the Fibonacci of 4 and 3. So we need to add 2 and 3 to get the 5. So this is how we will do it. And the easiest way to perform this or to solve this problem is by using a recursive function. So let's write this function. So Fibo, it will take an n, which is the number that we want to find the sequence. And basically we need, as I told you, we need to find the Fibonacci of the previous two numbers. So since I'm using a recursive call, I will call the function again and again. So I'm just gonna return the Fibonacci of n minus 1, which is this number. For example, if you want to find 5, so it's the Fibonacci of the fourth Fibonacci number, which is 3, plus the Fibonacci of n minus 2, which is the Fibonacci of 3, which is 2. And this will keep calling itself until it reaches any number less than 1. If it's less than 1, basically, so if we call the function and it reaches 1, so if n is less than or equal to 1, then we're just gonna return the number, or n. So basically, if it's 1, it will just return 1, and also if it's 0, it will just return 0, because there is no 0 Fibonacci number. And that's it. This is how can we get the nth Fibonacci number. So let's test this out. Console.log Fibo. For example, the fifth one. As you can see, we get 5. So if we tried the second one, we get. So this is working. But now let me walk you through what's happening really in this line, because there are two functions, two recursive call. So let's execute this function and then execute this function here. So let's say, for example, I want to get the Fibonacci, the third Fibonacci number. So Fibo 3. So what will happen is there will be, let's first execute the left side. So what will happen here is it will call Fibo on 3 minus 1, which is 2, and then it will call it again here on Fibo 2 minus 1, which is 1. So now this, because it's equal to 1, it will just return 1, but 2 also has a right side, right? So I need to also get the Fibonacci of 2 minus 2. So the Fibonacci of 2 minus 2 is just the Fibonacci of 0, which is just 0. So this side is just 1. 1 plus 0 is just 1. And the right side, which is this side, which is 3 minus 2, which is just the Fibonacci of 1. And the Fibonacci in 1 is just 1. So when you add up the 1 here and the 1, so the both of those, when you add up their values, you will get 2, and the third Fibonacci number is 2. So this is just how you can get the, like the execution of the function. So now if we want to get the sequence, all we need to do is just starting from the number 1, looping over the number from 1 until the number itself, and we call it, each iteration we call the Fibonacci to get the Fibonacci of the current iteration. So let's write the function. Let's say Fibo sequence. It will take a number, and we will just loop to the number from 0 or from 1. Let I is equal to 1, and until the number itself, so n, but not less than n, less than equal to n, and here I plus plus. So what we need to do here is just get the Fibonacci. We call the Fibonacci of I. So the first Fibonacci, the second Fibonacci, and we need to store it somewhere because the result will be an array. So let's create result array, and we need just to push this value here. So, and then all we need to do is just returning the result. So now let's test this function. So we call, for example, we want the first 5 Fibonacci numbers. Now we get the first 5 Fibonacci numbers. The first 8, for example, we get the first 8. But now let's improve the previous function, because if we try to, for example, get the Fibonacci, the 38 Fibonacci number, for example, we will get this number. But as you saw, it took a while because this function grows exponentially, because we call the function twice in recursively. So as we saw here, if we just, for example, want to get the Fibonacci number of 5, we'll need to get the Fibonacci number of 4, 3, 2, and then 1, and then here it will be 3 and then 1. So 3 and 3 here repeated will be both. I will call for the same input twice. But what if I just store it in somewhere and just check if this number was already calculated? If it's already calculated, so I don't need to calculate it again, I'll just return the value. So what I need to do is just store this in a variable, for example, called result, and instead of returning the n, I will just assign the result to the n, and here also assign the result to the recursive call. And then after I get the result, I need somewhere to store it, right? And to recognize, I need to actually pass an array. So I'll pass an array, and as a default, I will just make it empty. So I will store each result in this array, and the index where we will store in the array is the same number, the same index of the number. So for example, here array of n is equal to the result, so that when I want to check later, I'll write if array n is not equal to null, because if it's equal to null, that means it's still not calculated, and we need to calculate it. But if it's not null, that means it has a value, that means we already calculated, and we just return it. So now here we will just return the result, and here before we enter the function, we will check if we already calculate this number before or not. So the way we do that is we call array of n. If array of n is not equal to null, it means that we already have a value and we just return it. If not, we will just calculate it and we return the result. And also, since here we're calling the functions, we need to pass the array. And let's see what we get now. As you can see, we get faster. And let's, for example, write 108. As you can see, it was really fast. So this concept called memoization, it's used in dynamic programming. You can look it up. It's really useful and simple concept. It will improve your recursive calls. When you have a recursive call and you are calculating the same input again and again, so you don't need to calculate it again. You already calculated the value. You just need to store it somewhere and you return it when the next input matches the previous result. So that's it for this one. Hopefully you enjoyed, and please like the video and subscribe to see more content, and see you in the next one.